You ready? You ready? You ready? You ready? You ready? So in 13 here, they want to see whether or not this sequence converges. So what do? We're going to look for the limit as n goes to infinity, but before we get here, let's just try to clean that up. What am I talking about? If I had 3 to the n plus 1, could I write it as 3 to the 1 times 3 to the n? Because if I have the same base and I'm multiplying, what do I do to their exponents? Add them. I add them, for sure. So I'm going to go ahead and I'm going to do that over there. I'm rewriting that 3 to the n plus 1 as 3 times 3 to the n. Then I see I have a 3 in my numerator here and here, so I'm gonna factor it out. Why? Just because I think that it's gonna make it easier. So when I factor it out, that other 3 becomes a 1, and this example starts to look like a Tijuana taxi. So now what? I'm gonna pass that 3 out front because we know if we have a constant times a sequence, we can pass the constant outside of the sequence, and it's gonna be the same product. So I put that there. Then I go and I'm looking at the limit for that guy. Okay, so that 3's outside. We can use our limit laws and pass that 3 outside, all the way outside. Yeah, that way. So I had that 3 out front, so I don't have to worry about it. So now I'm going to go and I'm looking at that numerator and that denominator. When I evaluate that as n goes to infinity, we see that's infinity over infinity. And then let's go to the hop. Yo, baby. And the derivative of that is that because if you're looking at the derivative with respect to x of say b to the x, that's going to be the log of b times b to the x. Okay, so then that's what we're using there on our derivatives of our exponentials. So we then see that those are going to reduce. And I deduce that when I take the limit of that constant 1, your answer is 3. So what does that mean? That means your sequence converges. Because it goes to L, it goes to a specific number, and that number be 3.